All right, let's get started with Chapter 3, brand new chapter, where we're going to learn how to solve equations. The very first section is solving one-step equations, meaning we're going to apply just one single step in order to solve for the variable or the unknown. The goal here is to apply properties of equality and inverse operations to solve equations. We're going to learn a lot about what that means going forward. So let's start out with the vocabulary. Inverse operations are two operations that undo each other. For example, subtraction undoes addition. Multiplication undoes division. So addition and subtraction are inverse operations of each other, and multiplication and division are inverse operations of each other. That's what we're going to use to solve equations going forward. Equivalent equations have the same solution. For example, if I had an equation x plus 2 equals 6, if I just use mental math and I asked myself what number plus 2 equals 6, we would say 4. If I had another equation over here, x plus 5 equals 9, and I used mental math and I asked myself what number plus 5 equals 9, the answer would be 4. Because both of these equations have the same solution, they are equivalent. Okay, finally, to check a solution, you evaluate. Oops, I need my pen. You evaluate the equation by substituting. Same thing we did with expressions. By substituting your answer into the original equation. So exactly what we've done with expressions. All right, let's talk about properties of equality. It's a very simple concept that basically means we are going to do the same exact operation on both sides of the equal sign and still maintain equality. That's all it means. So for example, down here, let's look at the addition property of equality. If I start out here with 10 equals 10, I think we can all agree 10 equals 10, and I add the same exact thing to both sides of that equal sign. So in this case, I'm adding 2. I get 12 on one side and 12 on the other. I still have equality. Okay, let's look over here for the subtraction property of equality. That means we're going to subtract the same exact quantity from both sides of an equal sign and still maintain equality. So 16 equals 16. Let's just pick any number to subtract. Let's say subtract 10 from both sides. 16 minus 10 is 6. Over here, 16 minus 10 is 6. I still have equality. Okay, let's look at the multiplication property of equality. That means I can multiply both sides of an equal sign by the same thing and still have equality. Here, let's try multiplying both sides of this equation by 3. We're starting out with 5 equals 5. Let's multiply both sides by 3. And we end up with 15 equals 15. I still have equality. Okay, let's look at the division property of equality over here. And that means that we can divide both sides of an equal sign by the same exact thing and still maintain equality. So here, let's divide both sides by 4. I'm starting out with 24 equals 24. 24 divided by 4 is 6. And 24 divided by 4 is 6. I still have equality. So that's it. That's a simple concept. Whatever you do on one side of the equal sign, you can do exactly the same thing on the other side and still maintain equality. And this is very important in solving equations. Okay, turn to the next page. Let's talk again about inverse operations. So in math, we need a way to undo every operation. Every single thing in math that you can do needs an undo button. In Microsoft PowerPoint or Word or even on your cell phone, the undo is this backwards arrow. That's pretty much what we're doing with these inverse operations. So there are several undo buttons called inverse operations. And I do want you to get used to using that phrase, inverse operations. Every single operation has its own inverse. Okay, let's look at addition. How do we undo addition? We undo addition with subtraction. And how do we undo subtraction? It's kind of like yin and yang. We undo subtraction with addition. And as we already said, how do we undo multiplication? We undo multiplication with division. How do we undo division? With multiplication. And we just recently went over this in the last section of chapter 2. How do we undo squaring? In other words, x to the power of 2. We undo that with square rooting. This is the square root symbol. And how do we undo square root? We undo square root with squaring. Everything in math has an undo button. Okay, so how do we undo adding by 6? We would undo add by 6 by subtracting 6. What's the inverse operation of subtracting 18? The inverse operation of subtracting 18 would be to add 18. Okay, I want you to hit the pause button and fill in the rest of this table before moving on with the notes. Alright, let's get going with solving some equations. Alright, we're going to use the properties of equality and inverse operations to solve for the variable. You're going to hear me say isolate the variable or isolate the unknown. Those are two phrases I'm going to use a lot. So that just means get the variable all by itself. Okay, so what are we doing? Go directly to the variable that we're trying to solve for. That's key. Look what's around it and then use the inverse operation to undo whatever is around it. Whatever you do on one side of the equal sign, you have to do exactly. You must do exactly the same thing on the other side. That's key. Those are the properties of equality. Okay, let's take a look at this example here. X minus 4 equals 7. I know you're using mental math and you're saying what minus 4 equals 7, and you can immediately come up with 11. But I want you to practice using the inverse operations because the equations are going to get a lot more complicated. So here we have x minus 4 equals 7. I said go directly to the unknown. So go directly to that variable. Look what's around it. What is around it is subtraction of 4. We need to undo subtraction. How do we undo subtraction? Well, the inverse operation of subtraction is addition. So we're going to add 4 to get this subtract 4 out of there. But whatever we do on one side of that equal sign, we got to do exactly the same thing on the other to maintain equality. Okay, so if we add 4, if we add a number to its opposite, it's basically 0. Negative 4 plus 4 equals 0. 7 plus 4 equals 11. So x plus 0 is really just x. Okay, so we've completely undone that subtraction of 4 with addition of 4. Now how can we check our answer? We can substitute back in x equals 11 into our original equation. So I'm going to get rid of the x. I'm going to substitute in 11 to see if I have equality. So 11 minus 4, I'm hoping equals 7. And 7 does equal 7. So we have equality. All right, let's try number 2. X plus 3 equals negative 2. Go to the unknown. What's around it? What's around it is adding 3. I want to undo adding 3 with its inverse operation, which is subtract 3. Whatever I do on one side of that equal sign, I have to do exactly the same thing on the other side. X comes down here. Plus 3 minus 3 is 0. I'm sorry, I'm going to have to erase my mess here. Just doesn't look good. X comes down. 3 minus 3 is 0, so they just reduce out. Negative 2 plus a negative 3 is negative 5. So I think that's my answer, but I need to check my work. Go to the original equation. X plus 3 equals negative 2. Substitute. X equals negative 5. And I'm going to ask myself a question, really. Does this equal negative 2? Negative 5 plus 3, does it equal negative 2? It does equal negative 2. Different signs, take the difference. So I'm going to subtract those numbers. I get 2, and I'm going to give it the sign of the number that's farthest away from 0 on the number line. So negative 2 does equal negative 2, and I've checked my answer. So over here, what did we do? The inverse operation is subtraction. So inverse operation of add 3 is subtract 3. Let's take a look at multiplication. Here we have 8x equals 56. I said go to the unknown. The unknown is x. We're trying to solve or isolate x by itself. What's around? Well, x is being multiplied by 8. How do I undo multiplication? I undo multiplication with division. They are inverse operations of each other. So I am going to divide 8x by 8. If I divide one side of the equal sign by 8, I have to divide the other side of the equal sign by 8. 8x divided by 8, well, the 8's divided by 8 just reduces out to 1x, or just x. And then if I divide the 56 by 8, I get x equals 7. Let's check our answer. Go to the original equation, 8x equals 56. Substitute in 7 for x, so 8 times 7 equals 56. Again, I'm asking myself a question. Are these equal? 8 times 7 does equal 56. So I do have equality. This is a true statement. So I feel good that x does equal 7, and I've checked my answer. Okay, finally, let's take a look at division. Go to the unknown. The unknown here is x. What's happening to x? X is being divided by 5. How do I undo division? I undo division with multiplication. So, x is being divided by 5. I need to multiply by 5 to undo that. If I'm going to multiply a fraction by 5, I'm going to put that 5 over 1. Whatever I do on one side of that equal sign, I got to do exactly the same thing on the other side to maintain equality. So right now we're using the multiplication property of equality. Right here, this 5 divided by 5, well, they're going to cancel. If I multiply these numerators, 5 times x is 5x, 1 times 5 is 5, and over here, if I'm going to multiply this whole number, 12, by 5 over 1, I'm just going to multiply them together, which is 60. And finally, 5 divided by 5 just reduces out to 1. Anything divided by itself is 1. So x is now finally isolated all by itself. X equals 60. Let's check our answer. Go to the original equation. X divided by 5 equals 12. Substitute 60 in for x. See what we get. And again, we're asking ourselves a question. Do we have equality? Does 60 divided by 5 equal 12? It does. 12 does equal 12, and I've checked my answer. Okay, if you want to keep going with these notes and see if you want to practice using inverse operations to solve and check for the unknown, you are welcome to do so. Otherwise, you can end this video and we can do these in class.